Hello, do you own a Flashforge Finder 3D printer? Have you ever wanted to know how your print was going on when you're not standing in front of it? Well, I've been working on a project to do just that. It's based on an ESP8266 microcontroller. The idea being that the microcontroller will communicate with the 3D printer over Wi-Fi and send status reports to a Blink app running on either an iOS or an Android device. As you can see here, I've used a Wemos D1 Mini for my project. I've 3D printed an enclosure, added a power switch and an LED, and this has been hot glued to the side of my 3D printer. The small USB lead is plugged into the 3D printer USB socket, and that provides the power. Okay, so to make this project work, we need to make some changes to the 3D printer Wi-Fi configuration. By default, it's configured as an access point, and we need to change this to be a station so that it can use your home Wi-Fi. In the user manual, there is a warning, and I'll read the warning out now. It says, note, if you choose the STA mode only, the printer may be unable to connect Wi-Fi with the wrong STA settings. In this condition, it has the risk of being unable to connect to the Wi-Fi forever. Not very good English, but basically what it's saying is that if you enter the SSID or the password of your network incorrectly in the Wi-Fi interface on the printer, then you could render your Wi-Fi unusable on the printer. The printer will still operate correctly, but you will not be able to communicate with it over Wi-Fi as you've entered the wrong settings. Now, I've done this twice on my own printer without any issues, but I need to warn you that you do this at your own risk, and I accept no responsibility for your actions. So, if you're brave enough to continue, the first step is to access the Wi-Fi configuration pages of the 3D printer. Use something like Internet Explorer and browse to the IP address of your printer. By default, this is 10.10.100.254. On successful connection, you'll be prompted for a username, which is admin in lowercase, and a password, which is also admin lowercase. The first page will probably show you the system status, which is just an overview of your current settings. I would suggest you take a screenshot of that and save it. First thing we need to do is click on the left hand side where it says Wi-Fi set option. On this page we can set the Wi-Fi mode to STA, and there's a save button for that. We can also enter the SSID and password of your home Wi-Fi, and this is very important that this is done correctly. Case sensitivity and spelling are paramount. We can also disable DHCP and set your own static IP address, set the mask, gateway and DNS settings, and also there's a save button. This is a full screenshot of the Wi-Fi set configuration page. Suggestion here is for you to take a screenshot of this before you start and store away somewhere safe so that you have something to refer back to should you need it. Everything on this page that we need to change is circled in red, and starting at the top we have the Wi-Fi mode select. Set this to STA mode, and then just below there there's a save button. Click that and this part of the configuration is saved. The section below, we need to set the router SSID to the SSID of your home network. The STA password is set to the password of your home network. Please at this point heed the warnings. These two items must be entered correctly, that is the correct spelling and the correct case sensitivity. Then we can disable the DHCP, which allows us to set a static IP address. Here I've used 192.168.0.144, and that's the IP address that I'll be referring to when we look at the code later. Set the net mask, set the gateway, and set the DNS. Take a screenshot of the page after you've made these changes, and again store away somewhere safe. Click the save button. Once your Flashforge Finder is rebooted, you should see the Wi-Fi symbol appear in the top left hand corner of the touchscreen display. Now on my printer this takes approximately 45 seconds to appear. If the symbol appears, then that's a sure indication that you're successfully connected to your home Wi-Fi. So, assuming that your 3D printer is now connected to your home network, the next stage is to write the code for the ESP8266. For this, I'll be using the Arduino IDE coding interface. I suppose the first thing we should do before we jump into the IDE environment is to create a project in Blink. Now there are loads of tutorials to do this. Today we're just going to concentrate on how to create a simple Blink project for the 3D monitor. So first thing we do is click New Project. This will take us to the initial screen, and here we can enter the details for our project. So I'm going to give it a name. I'm just going to use 3D monitor. Then I'll select the hardware type. There's loads to choose from, but I'm going to just choose ESP8266 as that's the board I'm using. Then I'm going to choose a connection method. Typically this will be Wi-Fi. We click OK and we click Create Project. We now have a blank desktop, and this is where you would create and add your widgets and labels and whatever else you want to do. So here's a copy of mine. You can see I've got 5 labels, I've got 1 gauge, and I've got 1 email widget. So if we take the first field, V0, you can see it's a label value. The input pin is V0, and so on and so on. V1 and V2 and V3, V4, etc. will now be shown. If you want to duplicate my project exactly, just freeze frame the video and duplicate the settings that you see on these screens. Now when we get to the email widget at the end, you'll be prompted to enter your email address, and this is the email address that the completed message will be sent to. Now over in the IDE environment, for the code, first thing we do is we include a couple of libraries, and then we have 4 things that we need to set. So the first thing we need to set is your Wi-Fi SSID. Then we need to enter your Wi-Fi password. Then you need to enter the auth token that you were provided with by email once you'd created the Blink project. The 4th thing we need to do is to enter the IP address that you set during the Wi-Fi configuration section of this video. Once these are done, the first 3 variables here are just for the printed percentage. Then we have a variable for the printer response. We have a couple of variables for updating the Blink screen. We have a variable called /pos, which is used to calculate the number of printed bytes so we can work out the percentage. And then we have an email flag to decide whether we've already sent an email or not. Several variables here to cope with the elapsed time. We then initiate a Wi-Fi client, and we initiate a Blink timer. So within the setup routine, the first thing we're going to do is to connect to the Wi-Fi using the Wi-Fi SSID and password provided above. Then we'll start Blink, and then we'll start the timer, and this will send information to Blink every 200 milliseconds. We have a short delay, and then we're going to reset the elapsed time on the Blink. Another small delay, and then we're going to connect to the server. So connecting to the server will try and wake up the communications between the 8266 and the 3D printer. The loop here is just a very simple loop. We're basically going to start Blink and start the timer. Then in the connect to server routine, we are attempting to connect to the server. If we're successful, then the printer connected will be sent to Blink. If we're not successful, we say find a not connected in Blink, and then we reset all the Blink variables. And then the next thing we'll do is try and do a connection again. Okay, a small delay, and then we're going to send some G codes to again wake up the printer. So the next section, called send Blink, we calculate the elapsed time, and then we check if we are connected. So if we are connected, then we say find a connected, We then send the G-codes to the printer to get the status of the various actions, and then we look at the answer responded. So if it says printing byte, then we know that this is the part that tells us the number of bytes currently printed, and we can then use the following code to calculate the percent printed. So what it's using here is the /pos variable, and it's stepping back within the string to find the first space, and then from that it knows how many bytes have been printed. So then we calculate the percentage, and then we do a quick check. I have seen the percentage rise to 100.01. For some reason the 3D printer sent the wrong value, so just a quick check there to say if it's over 100, set it to 100, and then we do a quick check. If it's 100%, check if the email's already been sent. If it hasn't, then send the email, set the flag to sent, and update the job state. If the percentage is between 0 and 100, then we must still be printing, so update blink. If the percentage is equal to 0, then the job state is idle and update blink. Then we send a M119 command to the printer, and this gets the head status, so whether it's moving, whether it's heating, or whatever it's doing. And we send the response over to blink. Then we send an M105 command to the printer to get the nozzle temperature, and again we update blink with the response. We update the status of the printer, and we attempt to connect to the server. The next thing we do is we send a few blink updates, and then we move to the send to printer routine. Now the G-codes in this printer routine were taken from a live Wireshark trace during a print, and I've tried several combinations. The ones here seem to be the one that give me the best results. So we're sending probably 6 or 7 commands here in succession, and the final one, M27, gets us the majority of the information we need. So once we have all this information, we can go back around the loop and we can update as often as we need to. So before we can use the 3D monitor, there are a few things that we need to understand. Firstly, the 3D monitor must not be powered on when we're sending a file to the printer. Whether we're using Wi-Fi or USB to transfer the file to the printer, this is the case. Secondly, the printer Wi-Fi must be connected before the printer started. So typically you would turn on the printer, wait for the Wi-Fi symbol to appear, and then transfer your print and start printing. Thirdly, the USB lead must not be connected while we are monitoring, and this is because the Finder will not send any packets over the Wi-Fi, as it prefers to use the USB lead instead if it's connected. So to operate the 3D monitor, the first thing we would do is switch on the printer, wait for the Wi-Fi connection. Then we send the print to the printer, and again there's a note there saying if you're using the USB to send the print, disconnect the USB lead as soon as the file transfer is complete. Then we switch on the 3D print monitor. The Blink project should connect and the progress should be shown. When the print is complete and it gets to 100%, an email will be sent to the email address that we configured within the Blink project. At this point everything is complete and you can switch off the 3D monitor. So now I'll show you a quick demonstration of the 3D monitor in action. Well, you can see here that I've fired up FlashPrint and I've loaded a very simple 3D file. So the first thing we need to do is to send this file over to the printer, and to do this we click the Send G-code icon at the top. This will ask us how we want to connect, so we can choose either Ethernet or we can choose basically USB. I'm choosing USB and I'll click connect. If I connect successfully, I'm asked for a file name and then I can click OK. This will now send the file over to the 3D printer and the printer will start the print process. Okay, at this point the next stage for me is to disconnect the USB lead. Now that I've disconnected the USB lead, I can turn the 3D print monitor on. And over onto the Blink app now, we can see that the 3D print monitor is connected The status will shortly update, and currently it's showing 0.87%. The status waiting on tool means that we're waiting for the print head to reach temperature. The temperature set in the print job for this is 220 degrees, so basically not much is going to happen now until we hit the 220 degrees. So you can see the nozzle temperature is climbing steadily. The elapsed time is ticking away. Updates on here are approximately every 3 to 4 seconds. So we'll wait now until the nozzle temperature reaches the job temperature, 220 degrees, and then we'll notice that the percent complete starts to rise. As this is a 3 to 4 minute print job, I will speed up the video to 5 times normal speed so that you're not waiting for the 3 or 4 minutes for the print job to start. So here we are, almost at 220 degrees. And here we go. So we're now moving the head. So the head is positioning over the build plate and the print will start. So we're at 1.63%. It will then jump shortly to about 3%, and then I'll speed the video up. So here we go, 3.76%, and speeding the video up at 5 times its normal rate. You can see it's climbing 19%, 22%, and it'll go all the way through. Once it hits 100%, then we will see that it'll say job complete, the elapsed time will freeze, and the next thing it would do is send an email to your email address saying that the 3D print is complete, elapsed time equals whatever the elapsed time is. So almost there. So there's the 100% complete. The nozzle temperature is now decreasing, and the 3D monitor now has sent the email out, and you can power off the 3D monitor. So finally, thanks for watching. A link to the ESP8266 code should be in the comments section below.